All right, hello, this is Mrs. Short. I'm going to go over section 7.1 with you. It's on parabolas, and so you're going to do this, take these notes here. I'm going to try to treat it as if you were just taking the notes on your own paper. You could do that, or you can print out the PDF of the notes wherever your teacher posts those. And then remember, there's a math space assignment to do that's related to section 7.1, and here we go. All right, so parabolas. You guys already know about your basic parabolas, right? Basically you're used to this, a parabola having, just like a basic parabola. Sorry, my writing's kind of messy, but your standard form was y equals ax squared plus bx plus c. And then you had a vertex form, if you remember. It was a x minus h squared plus k. And the vertex was the h and the k. Remember, it's the opposite of what's in the parentheses, and the k stays the same. And so the real definition of a parabola is this. It says a set of points in a plane that are equidistant from a fixed point, called the focus, and a specific line called the directrix. Well, there's some things on here that you might never have learned. There is a line called the axis of symmetry. It goes right down the center, and that's basically the line that cuts your parabola in half. There is another line called the directrix, and the directrix is down here, a little bit ways away from your parabola, and that distance that it's away from the tip of your parabola is called the focal length. And I will also point out that there is something called the focus. Now the focus is inside the parabola right there. Right there. And so it's a point, and that length that goes from your vertex down to your directrix, and from this focus here to your vertex, that is called the focal length. And that's where you know where the directrix is because it's the same distance from the focus to the vertex as the vertex to the directrix, and I'll go over more on the next page. But anyway, that's what those two things are talking about, the directrix and the focus. So on this next page I have here, take a second and pause the video and maybe draw this picture. This is a picture from the book. So pause it up and maybe draw this to yourself. So what this is talking about, this equidistant these points that are equidistant from two places. So you see this right here. This is the focus, and it is, if you go to a point on the parabola from this point and then go back to the directrix, that line, these two lines are equal to each other. And so if you do that with anything, so like if you do it again, but you go, like, let's say up here, and you go back. So those lines are going to be, those segments are going to be the same. And so that's what the definition was talking about, a set of points in a plane that are equidistant from a fixed point and a specific line. And so you could do it over here as well. So if you went back here and you went over there and went back there, those would be the same length. So all those points get created all the way around this parabola. So this parabola is a collection of points that share that equidistantness. All right, so remember this little area right here? That's called your focal length. That little, add that to your graph. Now, the focal length is going to be represented with the letter P in the equations I'm about to show you. When you're on math space, the focal length is the letter A. They use A for some reason. All right, so before we go into what we have to do with parabolas, I just want to put a little prior knowledge, give that to you. Maybe if you guys were in Honors Algebra 2, you did what was called completing the square to solve quadratic equations. If you were not in Honors Algebra 2 last year, then you maybe didn't do completing the square. So anyway, here it goes. So when you have a quadratic, so this is kind of like old knowledge called completing the square. And if you had an equation like this, x squared, or an expression like this, plus 10x plus 32, and you wanted to put it in this type of format, x minus h squared plus k. So hopefully you recognize that's vertex form of a parabola. A couple of things are missing. There's no a right here because I don't have anything right there but a 1. So I'm not doing a more difficult problem right now. I'm just kind of keeping it easy. So what you do is this. To complete the square, you're going to group these two pieces together. So we're going to take x squared plus 10x and leave a little space, put a parentheses, and put that 32 back outside. Now, to complete the square, what you do is you look at this center item right here. So this number right here, you take half of that number in your mind and you square it. So half of 10 is 5, and 5 squared is 25. So I'm going to add 25 in here. Now, I'm not allowed to just add 25 randomly. I'm not allowed to just like add it and then go about my business. If I added 25 on the inside, I have to take it away somewhere else so that my problem is basically coming back to what this was to begin with. So I'm going to take away 25 out here. And so if I put everything back together, combine like terms, I basically just have what I started with, but I don't want to do that because the whole point is to put it in the vertex form. So this piece right here that you've created now, this is a perfect square. If you factor that, it will be x plus 5 times x plus 5 if you factor it. So basically it is x plus 5 squared. And then 32 minus 25 on the outside is a positive 7. So what you've done here is you've put this equation into vertex form. And so if somebody asks you for the vertex, you'd be like, oh, the vertex, it's at negative 5. So left 5 and up 7, there's your vertex. And if you put a little y equals here to make it like an equation, right? So these problems get a tiny bit harder if there is a leading coefficient in these problems. So I'm going to do this example kind of similar. It's y equals 2x squared minus 12x minus 1. I'm going to put that in vertex form like we just did. Now with these problems, I still group these together, but as I group them, I'm going to divide out the 2. So I'm going to factor out the 2. So I'm going to divide it out so I'd have 2, parentheses x squared minus, this would turn into a 6x, leave a little space, and the negative minus 1 just sits out there. He does nothing. So now, again, same thing. I'm going to take half of this number and square it. So half of negative 6 is negative 3, and negative 3 squared is positive 9. So again, this last thing that I'm adding here, I'm always adding plus 9, adding the thing. So now, remember, my problem has to turn back into this. So I can't do anything that, I have to basically negate everything that I have put in here. So I'm adding 9 on the inside here. But remember, this 2 is going to affect everything here. So really I'm adding 9, but I'm really adding 18 because 2 times 9 is 18 if I multiply this out. So I have to subtract 18 out here. All right, so let's put it in the format. Y equals 2. I got a perfect square here. This is minus 19 on the side. And x squared minus 6x plus 9, this guy right here, if you factor it, that would be x minus 3 times x minus 3. All right, so if somebody asked you, you had to do the vertex. You say, oh, the vertex is 3 and negative 19. All right, now don't forget, you can also do this. We're going to have some parabolas that are not normal, like to what you're used to. They're not facing up and down. They're not parabolas that are facing up like you used to, or maybe parabolas facing down like you're used to. There are going to be some parabolas facing sideways. And so instead of having y equals, you could have x equals. So let's practice that a little bit. Let's say you're given a parabola x equals y plus 4 squared minus 6. So with that one, you can also get your vertex. The x part, though, is sitting right here. Now that piece is outside the parentheses. It's true to what the number it is. So that would be negative 6. And the y part is sitting in here. It's in the parentheses, so it's opposite of what it is. So it's positive 4, so I'm going to put negative 4. So let me take a second and show you on on Desmos. If you go to Desmos, you can type these things in and get a picture of what's going on. So I'm going to do that real quick. All right, and with Desmos, you don't have to solve for x or y. You can just type in what you have. So I have this last one, x equals parentheses y plus 4. All right, so I have it on my iPad, but you guys you can put it on your computer or whatever you want to be using. All right, let's see, minus 6. All right, and so there it is. And so there's that parabola, it's sideways, and so that's not something you're used to, but we're going to talk about that in 1 minute. All right, remember you can click on some of these if you want to know some of the points. There's your vertex, negative 6, negative 4. Here we go. All right, So the main idea of this section here is you're going to have kind of a new looking format, another setup for your parabolas and your equations basically. So here it goes. So here's your new setup. You're going to have parentheses x minus h squared equals 4p and then times y minus k. And I'm going to explain these things in a minute. And also it's going to be the reverse of that in a second, but we'll leave that other side. All right, so this setup here, notice my x is being squared over here and my y does not have a square on it. So just pick up on that fact here. So my parabolas are going to look like this. When x is squared, my parabolas either face up or they face down. Now that all depends on if you have a negative p-value. If this p-value right here is less than 0, then your parabola is going to face down. It's going to open down. And if your p-value is greater than 0, then it's going to face up. Okay. All right, so here it goes. So this format right here, your vertex is going to be like it was before, h comma k. So you're going to pick out those numbers and that's going to be your vertex. Your focus. So remember your focus. Sorry, I wrote that kind of ugly. Oh my God. Focus, F-O-C-U-S, is going to be that point like in the middle or like right above the vertex or right below the vertex where your parabola is kind of centered around. All right, so your focus in this situation is going to be h stays the same and you do k plus p. We'll do a couple examples of these. And then your axis of symmetry. The axis of symmetry is going to be that line, remember, that goes right down the center. And so your axis of symmetry in this situation is going to be x equals h. And then you have your directrix. And that is going to be that line that's the same distance away from your vertex as your focus, going the opposite way. And so that directrix is going to be y equals k minus p. Now we have the same type of formulas for the other situation, and the other situation is when y is squared. So I have y minus k squared equals 4p, and then I have x minus h. All right, so that situation is either a parabola opening towards the right, that is when your p-value is greater than 0, and the other situation, so or, that's the word that I wrote in the middle here. Sorry. Or your parabola is going to be opening towards the left, and that is when p is less than 0. So your vertex is still going to be h and k. Your focus is now going to be h plus p, comma k. Your axis of symmetry is going to be y equals k, and your directrix is going to be x equals h minus p. So I'm going to show you a couple examples of those, and then we'll be all set. Remember, you can graph these things on Desmos to get an idea. So my first example here is going to be given this equation, y plus 5 squared equals negative 12 and x minus 2. So my vertex is hk, so remember it's this guy and that guy. So it's 2 and negative 5. My focus. So my focus here now, remember this, the y is being squared here. So y is squared means your parabola is going to open to the right or to the left. And since these I have a negative right there, it's going to be a parabola kind of facing this way. Okay, so my focus is going to be, I'm going to go back and use this piece right here. My focus is going to be h plus p, comma k. So first of all, let's find our p-value. So my p-value has to do this negative 12. So that means that 4p equals negative 12. That means p is negative 3. So that means I have to do h plus p for my focus. And so h is 2, and plus negative 3 is negative 1. And then my negative 5 stays for k. My axis of symmetry in this situation is going to be y equals the k value. Well, this was the k value right here, so it's going to be y equals negative 5. And my directrix is going to be x equals, and remember it's x equals h minus p. So here was h, and so it'd be 2 minus negative 3, that is 5. All right, so this picture over here was just kind of random. All right, so let's draw this up a little bit. So I have my x and my y axis, and I'm going to draw this on here. Let's see, my vertex is 2, -5. I'm just going to freehand a little bit, so over 2, down 5, about here. My focus is -1, -5, so -1, -5 are about there. So that means my parabola is like opening up towards that direction there. All right, and my, let's see, my axis of symmetry is y equals -5, so it goes right through the focus and the directrix. I'm sorry, the focus and the vertex. And then my directrix is right back here, and that is x equals 5, right about back here. Okay, so there you go, and you can get the rest of the picture by graphing that on what's it called, on Desmos. But you might need to know one other point on the graph just to help yourself out. So if you ever need to know one other point on the graph, I would recommend just plugging a number in for x or y. Now you want to be smart about it. You have y plus 5 squared. So I'm going to put the number 1 in there. So I'm going to let y be 1, and let me show you why. So if y is 1, I will get 1 plus 5 squared, which is 6 squared. That's 36. Well, I will get 36 equals -12 times x minus 2. So notice I picked something to make a multiple of 12. Well, 36 divided by -12 is -3. And then I get x minus 2. Add 2 to both sides. I get x equals -1. So there's a point on my graph, -1, 1. So I didn't do too bad. -1, 1, maybe about right there. I mean, it's not perfect, but in case you need to know another point, you can just plug in a number. All right, we're going to do one more example, and that is of just a good old regular parabola. So here we go. So if I had x minus 6 squared equals 4 times y minus 3. So notice x is being squared, and my 4 there is positive. So that's going to be a good old parabola just facing up like normal. So let's figure this out now. Not y equals. 4p equals 4. So p equals 1. Remember, that's called my focal length. That's the distance between the focus and the vertex. All right, so let's get rid of this picture because it's not really right. All right, so my vertex. So my vertex is sitting right here. It's 6 and 3. All right, and then my focus. For this situation, my focus is going to be h plus p. I'm sorry. My focus is going to be h and k plus p. So h and k plus p, let's see. So h is going to be 6 and k plus p, so 3 plus 1 is 4. My axis of symmetry is going to be x equals h, so I'll have x equals, well, h was 6, so that stays 6. And my directrix is going to be y equals, and the formula says k minus p, so k is 3, and 3 minus this p value, 3 minus 1 is 2. So if you try to draw that up, 6, 3 is your vertex, so over 6 up 3. Your focus is 6, 4, so a little bit like right there. And this thing is then facing up. And your directrix is down here, y equals 2. So y equals 2. And your axis of symmetry, x equals 6, right there. And you can also graph on Desmos. All right, I'll see you later. Bye-bye.